So to keep the information coming from the network layer as a frame, there are two types of frames are available, two types of framing method. So keeping the information in a frame is called what we can say is framing. There are two types of framing methods are there. One is the fixed size framing. That means every frame will have the same size. Every frame will have the same size. Irrespective of the information to be transmitted, the size of the frame is same. So that is the meaning of fixed size frame. The second is variable size frame. So every frame may have its own size. Maybe some frames, say for example, for understanding purpose, a frame may have n bytes. Whatever frame I am sending now, it may be having n bytes. When I send next time, maybe tomorrow, it may be m bytes. Maybe day after tomorrow, it may be k bytes. After that, it may be some L bytes. After that, maybe some X bytes. So that is the meaning of variable size frame. There is no guarantee that every frame will have the same size. That is the meaning of variable size framing. Okay, so we'll see one by one how it is, how they are. The first is fixed size framing. So in the fixed size framing, irrespective of the data information that is to be transmitted from the network layer to the receiver side. So the network layer will be sending the information to data link layer, and the data link layer is going to transmit that in terms of a fixed size frames. For example, if you take ATM cells, every frame will have 53 bytes. Out of 53 bytes, 5 bytes will be the header and 48 bytes will be the data part. So every ATM cell will be moving from sender to receiver with 50 bytes, 53 byte size only. So as a result, it is easy to identify what is the beginning and ending of the frame. So after every 53 bytes, one frame is over. So that is why there is no specific identity is needed to find out from where to where is the frame. So it is easy to identify the frame, ending of the frame, then beginning of the next frame can be identified like this because fixed size. So every 53 bytes, one frame. Next 53 bytes, another frame. Next, another frame, likewise. So no specific indication is needed in this. That is the biggest advantage. But the problem is there is no guarantee that. So the information that is coming from the network layer will fit into the full size of the frame. Suppose I want to send some 100 bytes. So my network layer want to send some 100 bytes to the receiver. Then the 100 bytes will be handed over to the data link layer. Now the data link layer will put these 48 bytes in one particular frame and 5 bytes will be the header it is going to add. So out of 100 bytes, my first frame will have 48 bytes plus 5 bytes of header. So this 53 size by frame will be transmitted. Then the second frame will be including another 48 bytes. Now with these two frames, 96 bytes of information is being transmitted. So 4 more bytes are left. But the third frame needs 48 bytes of data, but only 4 frames are there. So likewise, a particular frame or the last frame may not be completely filled. These are the possible problems when we are using a fixed size framing. So in that case, one particular solution to solve that is a padding is used. So remaining unfilled place is being filled with the pad. So that is how now fixed size framing is being maintained. Fixed size framing is being maintained and it is being transmitted in the network. Okay, that is about the fixed size framing. So because of this padding, unnecessary additional transmissions which leads so the bandwidth reduction, unnecessary utilization of the bandwidth, cost, all these things comes into picture because of that. So instead of using the fixed size framing, maybe variable size framing is preferred.